Today's work is like the first session machine instruments right? So we have other two length measuring instruments to be discussed. Like I think we completed vernier principle, vernier caliper, about the vernier caliper, how it works, how we get measurements, right? Why vernier caliper we use, and also the periodic microscope. And then we also last week we did discuss the practical, how to measure the internal diameter of a capillary tube and how to get a reading for internal diameter and external diameter of a rubber tube. Right? So we have already finished those sort of things. Like the about the circular vernier scales. Did we? No. Only measuring vernier scales with linear vernier scales. Extended vernier scale. Yes or no? Extended verniers? Yes. Right. So I think today's paper includes one question about vernier, and I think it is not a linear vernier scale. Right? It is about some degree over angle measuring scale there, right? So before we move on to the micrometer or screw principle, I think we need to cover the small part of the vernier principle, which is actually the vernier scales are not only used in length measuring instruments, right? So vernier scales also used in angle measuring instruments, such as spectrometers. Have you ever heard of spectrometers? Yes or no? Yes, where? Chemistry, I think photochemistry or something. No, electron. Nothing. That absorption spectrums, those sort of things are right. So we use we also have that instrument. We need to. We are going to learn about the spectrometer, and there are three practicals. We actually three practicals we need to use spectrometer there in optics. Right? After complete the prisms, refraction through prisms, there are three practicals to be discussed. With the help of spectrometer, we are going to do it. Right? The spectrometer can get the angle measuring vernier scale. And there's another instrument called theodolite. Right? That instrument most commonly used by the surveyors. Surveyors to measure the angles, right? Like the measure angles, right? So precise angles they used. So we are not going to discuss about theodolite here, but in a spectrometer, when you're doing spectrometer practical, you need to get readings from the spectrometer, right? So there you need vernier principle, right? So nothing different there, right? The expression for least count is same. The similar expression we use, right? For angle machines, least count of the instrument is given by value of the one division or single division, value of the main scale division, value of the main scale division. Right? So it is the least count is the difference of the value of the main scale division and value of the vernier scale division. Only difference is vernier scale is a angle measuring one. Vernier scale division. Right? So let's take an example. So normally spectrometers, the main scale has calibrated in half degrees. Right? The small, there's a main scale. In main scale, this main scale has calibrated in half degrees, which means the value of a main scale division is 0.5 degrees. 0.5. So if we have 0 mark here, this is 0.5 and 1 degree, 2 degree, like that. Right? And the vernier scale. The vernier scale has constructed mostly 29 main scale divisions. 29 of main scale divisions calculated into 30 vernier divisions. 29 into 30. Right? So normally in typical spectrometers, main scale has a least count of 0.5 degrees, half degree, right? And vernier scale has constructed by dividing 29 those half degrees divisions into equal 30 parts. So what is the least count of the instrument? So because the least count, value of the main scale division is half degree. So half degree. Value of the vernier scale division, value of vernier scale division is half degree times 29 is the length of the angle of the main scale, has divided in 30 equal parts, so which is 29 over 60 degrees. So this is what the value of the vernier scale division. So which is 29 divided by 60. Right. So least common multiple of these two fractions is 60. So there are 2 into 30 is the 16, and right, 30 minus 29 degrees. So 1 over 60. Right? So least count of the instrument is 1 over 60 degrees. Right? So in minutes, 1 over 60 degrees means in minutes, how many minutes? You know the relation, right? Conversion factor between minutes and degrees. 1 degree equals 60 minutes. So that means 1 over 60 degrees, 1. So this is 1 minute. The least count of the instrument is 1 minute. Right? So now we have such a scale. So how do we get the reading? How we get the reading? So this is the scale. Right. So this is the vernier scale. So it has how many parts? 30 parts there. 30 there. More visibly paid the coincide with the home element, right? Parts gonna be the first and ready there. Right? Right? So actually this one is the vernier mark in line with the main scale division. Right. So can you tell me what is the reading of this instrument? How you get the reading? First thing you need to find out the main scale reading. So reading of the scale is, first you need to get main scale reading. Main scale reading plus, then you need to add vernier scale reading to it. So what is the main scale reading here? Suppose the instrument is this one. It has a least count of 1 minute. Right? Okay. So can you tell me what is the main scale reading here? Like the vernier caliper, you get the value of main scale deviation. So you can read up to nearest half degree. So these are 1, 2 like that. These are half degrees: 0.5, 1.5, 2.5. So what is the main scale deviation reading? 2.5. So vernier scale 0 here. Just before the vernier scale 0, the main scale division is 2.5 degrees. So it is 2.5. You can write it as, it is in degrees. So either you can write it as in the minutes, right? So I'm going to deal with degrees. Degrees only, yeah. Like 2.5 is the main scale reading. Then what is the vernier scale reading? How you get the vernier scale reading? The first thing you need to find out which vernier mark is in line with the main scale. So which one? Which one? Can you see this now? Actually, this one. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Let's say 10 one. Right? Vernier division is 10. So least count of the vernier is. So now you're going to use minutes or degrees here. You need to. You can't use minutes there because here this part is we put this main scale written as a degree value. So use the degrees here, right? 1/60 degrees. 2.5 plus 5. 10 times 1/60. 10 divided by 60. 1/6 degrees. Right? So what is 1/6 degrees? 0.1666 degrees. The value is 2.667, but you can't. 2.667. Get it? Degrees. Sorry. Can you give this measurement to this precision? Degrees only decimal clear. Yeah, you can. You can. You can make it 0.1. Like 1/60. Right. If you are going to use in minutes, this is how you need to do. 2.5 degrees is, you can express this in degrees and minutes. 2 degrees and 0.5 minutes mean it is a half degree. Degree can bargain. Right? So how many minutes are there? 1 degree equals 60 minutes. So half degree is equal 30. So this is 2 degrees and 30 minutes. 30 minutes plus number of the division, vernier division in line with the main scale is 10. And the least count is 1 minute. So it is 2 degrees and 30 plus another 10. 40 minutes. 2 degrees and 40 minutes. So that must be the final answer. Right? Degrees and minutes. Right? You can express the answer like this. This is fine now. No need to use this make a mode now. It is not compulsory. You can use degrees and minutes. These are allowed units. අපි දැන් degrees කියන එක එක මේ අතන මේ assignment එකක් නෙවෙයි. allow ratings assignment, but you can express the answer, right? එහෙමයි එහෙනම් degree 12 එකක් තියෙනවා reading එක ගන්න පුළුවන් වෙන්නේ. right? comment පොඩ්ඩක් ලියන්න. but circular vernier scales. Circular vernier scales. Circular vernier scales. Circular vernier scales. Yes. Right, right, the circular vernier scales. Vernier scales are right. But the topic circular vernier scales. Out of that, vernier scales are found. Vernier scales are found not in instruments, not in instruments, having length measuring, having length measuring, having length measuring scales. But also in instruments, having angle measuring scales, but also in instruments having angle measuring scales. Examples: spectrometer, then another one, theodolite. Right. Next line. In these angle measuring scales, same principle is used. Same principle is used. Please count of such a scale. Please count from such a scale is also given by the following expression. Right. Write the expression. Least count value of the main scale. Value of the main scale. The value of the main scale minus value of the vernier scale. Right? Then the expression is numbers here. Only expression. Right? Write only the expression. Value of a main scale division minus value of a vernier scale division. Right. Then the next paragraph. The spectrometer. The spectrometers. The spectrometer typically used. The spectrometer typically used consist with a main scale which is calibrated in 0.5 degrees. 0.5 degrees. 0.5 degree divisions. 0.5 degree divisions. The vernier scale is constructed. Vernier scale is constructed by dividing length equal to 29 divisions. Length equal to 29 divisions. In the main scale, into equal 30 divisions. Into equal 30 divisions. But then write the least count of the instrument. Find the least count. Least count of the instrument is 1 minute or 1/60 degrees. Least count. Least count. Right. Okay. Then write the example. Throw the scale and in the reading. Throw the scale and get the reading. Yes. Write down up to here. Starting from here. No need to write this expression again, right? We already wrote this. Right? The value of main scale division is half. Then this is the value of the vernier scale division and take the difference. Why? What is the confusion? No. Then thereafter, come the example. Drawing, get the vernier scale division. So this is relevant to this part. Huh? This is how we get this. Right? This is now that 29 or 60. Okay. Half decrease marks. Yeah, length of the 29 divisions is half decrease 29. That's divided to 30. Make up an idea. ඒක පැත්තකින් ලියා ගන්න. මේ අර 29 බෙදීම 60 විදිහට ඔප්පේ ගත්තේ. half degree of 29 තිබ්බා. ඒක length එක කියන්නේ angle එක වෙනස් ගන්න. So 29 into half divided by 30. So this is the value of the vernier scale division. Value of the vernier scale division. Right? Make පැත්තකින් ලියා ගන්න. මේක ආවේ කොහොමද 29 over 60 ආවේ දෙක කියලා බලන්න. ඒක ආවේ කොහොමද? Main scale divisions 29 තමයි 30 වලට divide කරන්නේ. So එක division එකක් කියන්නේ in decrease half 0.5 decrease. 0.5 decrease into 29 over 30. Vernier scale division. Okay, value with. Then get the subtraction and get the answer. Right, then throw this figure and get the reading. Roughly understand? No need to draw this. Draw scale. Roughly understand? If you have finished this, you can go to the question number 30, page number 12. We have finished. Well, you can go to question number 30. Page number 12. On page number 12. Look at this. Finished. Answer. Question number 13. Is that the one that's the thing? The high structure market. Okay, make the stick away. Measuring instruments. Vectors remain. Measuring instruments. Page number 12. Turn to page number 12. Question number 30. Like, from the way. Good, no? Finished? Okay. Like, in a spectrometer, circular vernier scale has divisions which are each degree divided by 2. Divided by 2. Divided by 2. Like, the vernier scale is prepared by dividing regular divisions of a main scale into 30 equal divisions. What is the least count of the instrument? So same scale, eh? Same scale we have discussed earlier, right? So least count is 1 minute. And least count is 1 minute. Then the thing is you need to get the reading. So what is the correct main scale reading? Someone, like, what is the main scale reading? What is the main scale reading here? Some 31.5. Agree? 31.5. Right, 31.5 degrees. Right, or either you can write it as 31 degrees and 30 minutes. Right? 31 degrees and 30 minutes. Right? I will do the both the methods. Right, then which mark, which one is the is in line with the main scale? Is it 12? 12? 12? Yes. 12 vernier mark. 12 vernier mark. Right. 12 into least count is 1 over 16 degrees. Right. So if you go with the minutes, 12 into 1 minute. Right. So 31.5 simplified is 12 over 60. 1/5 0.2. So it is 0.2 degrees. So answer is 31.7 degrees. If you get the answers in degrees, answer in degrees should be 31.7. Right? If you get the answer in degrees and minutes, the answer should be 31 degrees. 30 minutes plus 12 is 42. 42 minutes. 12 is the 12 එක නේද? coincide වෙන්නේ. මේ method දෙකම මම හැදුවා. මේ දෙකෙන් කැමති එකක් ගන්න. Many degrees වලින්. 12 into 1 over 60. Right? So 1 over 60 can 12 over 60. 1 over 5. 1 over 5 can 0.2 degrees. 31.4. 31.5 plus 0.2 is 31.7. Or if you use degrees and minutes, 31.5 degrees is 0.5 degrees equal 30 minutes. Right? This is the relationship, right? Remember, 1 degree is equal to 60 minutes. That means 0.1 degree is equal to 6 minutes. 0.1 degree is 6 minutes. So here you have 0.5. 6 times 5 minutes. Again, 30 minutes. Here you have 0.2. When 0.2 minutes, which means 12, sorry, 0.2 degrees, which is 12 minutes. 0.2 degrees equal to 12 minutes. So 30 plus 12, 40. Other question paper के टिप्पणी है देखा आपने और ये करने दोनों ने क्या आंसर किए देते question number 7 go to question number 7 of the tutorial take up it question number 7 so now you can get the answer for question number 7 same vernier scale least count is 1 minute. You get the answers. Answers are given in degrees and minutes. So what is the main scale reading? 170, 1 to 2.5. Main scale reading is 170. Question number 7. Today's paper. 172. Only 172? What is here? 0.5 mark. So it is 172 degrees and 30 minutes. Main scale reading like so which vernier mark is in line with the main scale? It is fourth one. Like 4 into this count is 1 minute. So answer is 172 degrees 34 minutes. Answer is 3. Answer is 3. Right. That's it. So now all the things related to verniers are over. Now write a topic. The topic is screw principle. Screw. Screw principle. Screw principle. Screw. So there are two principles we use to measure precision measurements. In order to get the precision measurement in lengths, small measurements done up, we use two methods. Right? One, we have completed that part, vernier principle. The second one is screw principle. Right? So I think all of you have seen what the screw can do on the screw right. Suppose this is a screw. It has a tip at one end, the other end it has a head. Head right. And what tails it has? What tails it has? Screw එකකදී මොනවද තවදී head එකක් තියෙනවා, tip එකක් තියෙනවා. Right. So this is the threads of the screw. Right now, so I would like to ask this question from our from the boys, from the girls, right? So normally, when you rotate the screw in order to advance it forward, what is the hand you need to rotate the screw? It is clockwise or anti-clockwise? Clockwise and in clockwise. If you rotate this screw in clockwise, it advances forward. Yes, agree. Boys, agree. Yes or no? In order to tighten the screw, you need to rotate arm in clockwise. Right? So I remember that in these measuring instruments we are going to discussing after this. All these instruments have a right hand screw principle. When you turn this screw clockwise, it advances forward. Right? If you want to get it back, you need to turn it anti-clockwise. Right? Right. So the thing is, these are the things we call threads, right? So in these screws, the length between two adjacent threads, this length. So why this length is important? When you turn this screw full circle, or one turn, how much of distance is advanced forward? If you turn this screw, if you rotate this screw once, right, that means you rotate it full 360 degrees. So what is the distance this screw goes forward? The distance is equal to the length between two adjacent threads. Right? So that length is, suppose it is simple x, we have a specific name to that. The length between or gap between two adjacent screws or two adjacent threads, we call it as pitch. Pitch. Not the pitch in music. Pitch. This is also pitch. Pitch can frequency. Right? Right. Again, here, if you turn this screw once, or you can turn this screw as it turn one rotation, so it goes forward, the distance equal to its pitch. Right. So if you want to measure small distance, right? So normally in the instruments we use in here, normally this pitch is 0.5 millimeter. It is 0.5 millimeter. Right? Pitch is 0.5 millimeter. Normally 0.5 millimeter. Right? So this is not a small one. 0.5 millimeter, you can see the 0.5 millimeter marks. Right? So what happens if you divide this circular part, the head of this screw, into certain numbers or certain divisions? Right? Suppose we have divide, right, this circular part into simple n divisions, right? So we have calculated this head, or you can say it is as a timber, right? So you calculate this timber into equal n divisions. Where divisions n on make a divide here, right? So when you rotate this timber or head of the screw, simple n number of rotations, what is the distance that screw advances? If you rotate simple n number of divisions, so what is the length or what is the distance the screw should advance? N number of distance means one full rotation. And the full rotation a distance equal to pitch of the screw. So distance is x. So what if you turn one division of the mains, one division of this circular scale? Now we are rotating one division. So what is the distance that the screw advances? X over x. So this is the least count of this x over x. Pitch over n is the number of divisions in the scale, circular scale. So this is known as least count of the instrument which has screw principle. It's very simple. Least count is pitch over number of divisions in the which scale? Circular scale. Scale is circular. It's not a linear scale, circular scale. Right. So tell me, a pitch of a micrometer is half, and its circular scale has 50 divisions. Circular scale has 50 divisions. So how do we get the least count of that instrument? Pitch is half millimeters. And how many circular divisions in circular scale? 50. So 1 over 100 is the least count. So it is 0.01 millimeters R. So the principle, the screw principle, the instruments that screw principle is used, it has a least count of 0.01 millimeter. Right? It is much more sensitive than the vernier caliper. Vernier caliper 0.1 millimeter, it is more than sensitive, right? Right. So this is how you get the least count of the instrument, right? So there are two instruments which screw principle is using. One is micrometer screw gauge. The other one is barometer. Right. So we are going to start micrometer screw gauge today. As barometer So both of these instruments, least count is we can find the least count of both of these instruments by using this expression. Make it right? So now you know the principle, how this works, right? If you turn the screw once, it goes forward, distance equal to the gap between its two adjacent threads, which is known as pitch. So they have calibrated the head of the, or you can say timber of the screw into n equal parts. This n can be 50 or 100. Typical micrometers, this is 50. For typical barometers, it is maybe 100. Right? Right. So this is number of n parts it has in circular scale. If you turn this n number of divisions, screw will go further. So screw advances simple x distance or x millimeter distance. And so least count is the least amount of distance you can measure. You can adjust or you can turn this circular scale one division. So if you turn the timber one division, then screw will go forward x over n distance. So that is the least count. It's the least count. It's a calculator. Yeah. Right. Okay. I topic you want yeah. The topic screw principle. Right. Yeah. Screw principle. Screw principle. Screw principle. Screw principle is the another principle we use to measure small length length LNT right. Yeah. The micrometer screw gauge. The micrometer screw gauge. Micrometer screw longitudinal gauge and spirometer. Spirometer. Build up by using screw principle. Build up by using screw principle. Next paragraph. When a screw is rotated, when a screw is rotated through a when a screw rotated one complete when a screw rotated through one complete revolution, it advances along its axis. Along its axis by a distance equal to the pitch of the distance, pitch of the screw. By the distance equal to the pitch of the screw. Right? Within brackets, yeah. Pitch is the distance between two adjacent plates. Click on it. So X is the pitch. Draw this. Right, mechanical term. Right, and then mechanical. Right, right. Then right. No. What do you mean? Well, I meditate. Right. What are the other school? What time was it? Right? Then yeah, suppose, suppose timber of the suppose timber within bracket head. Suppose timber within bracket head. Suppose timber of this timber timber of the screw has divided into timber of the screw has divided into simple n equal divisions. Simple n equal divisions. Right. So now you can prove this. Simple of the screw as divided simple n number of divisions. Putting other divisions that's fine, right? Right, yeah, no. Right class equal equation I make it memory is equal right, yeah. The distance equal equal sentence is like equal sign right? Over here distance the distance the distance is the distance screw advance the distance the screw advance when the timber complete when the timber completed one revolution one revolution completed, one revolution within bracket, simple n number of circular divisions. Within brackets, simple n number of circular divisions. The distance is screw advanced when the thimble complete one full revolution within bracket, simple n number of circular divisions equal to simple x. Simple x. Okay, equal to exam. If the couple is equal to simple x. Then make a minimum line. Right? Make a minimum lines. Right? That's okay. Equal to simple x. Okay, equal to right? Then next sentence, the distance screw advance, the distance screw advance forward when thimble complete, when the thimble complete one small division, thimble completed one small division, one small division equal to x over n. Completed one small division, right? Equal to x over n. Right? This is the least count of the screw principle. Least count of the screw principle. Right. So write the expression for least count. Least count is pitch over number of divisions in the circular scale. Write down this. This is a expression you need to remember. Least count is pitch over number of divisions in the circular scale. Right. Also from a side like this, sometimes a couple of picture right? In an instrument, when the screw moves or the screw completed 2 full cycles, it goes forward 1 millimeter. Yeah, please count equal pitch over number of divisions in circular scale. Right? And sometimes they are not giving the pitch directly. When the thimble complete 1 full cycle, screw goes forward 1 millimeter. When the thimble of the screw rotates 2 full revolutions or full rotations, tip of the screw goes 1 millimeter. 2 revolutions, around 1 millimeter. So what is the pitch of the screw there? How do you get that? Distance moved divided by number of revolutions. So pitch, you can get the pitch from this expression. Pitch of the instrument is given by distance moved divide by number of revolutions. Number of revolutions. मेरा आइटम करना. Pitch of this screw is equal distance moved over number of revolutions. Number of revolutions. Right. Write this as example there. Example. An instrument where screw principle is used. Screw principle is used. Has a circular scale. Of 50 divisions. If the pitch of the screw is half millimeters. What is the least count of the instrument? Right. Simple. Already done. Answer is 0.01. Second one. Second example. The spindle of a micrometer. The spindle of the micrometer, spindle, S-P-I-N-D-L-E, spindle of a micrometer, right? So spindle of a micrometer is equivalent to the this area of a screw, right? When we make it, spindle of a micrometer, make it, right? Micrometer moves 2 millimeters. When the thimble is rotated through, four complete revolutions. The circular scale has 50 divisions. Find the least count of the micrometer. Right? Answer? Sorry? 0.01, same answer as previous, right? Which is distance moving through this 2 millimeters, and the number of revolutions is 4. So it is half millimeter is the pitch, then divided by 50. Right? 1/100. Right. Okay. The next topic is micrometer screw gauge. Micrometer screw gauge. Micrometer. Micrometer screw gauge. Right. So short term is MSG. MSG micrometer screw gauge देगा आप सामने short term MSG, right? Message. Message. Right. So what is micrometer screw gauge, and what are the measurements we're going to take from this instrument? As the name says, micrometer. Micro means micro means order of micro. Micrometer extremely small, yeah. Much as small. Micro prefix is -6. 1 millionth of meter. Million in a. So you can use this instrument to measure 1 millionth of meter. Meter in million nekaka count of micro. Just that precision. So therefore we call it micrometer screw gauge, because it uses screw principle. The screw can again ethering. Gauge can normally we use gauge term to the things we need. We measure diameters like that. Gauge. Especially this instrument is used to measure the diameters of the thin wires. Guitar strings, again, thin wires, violin strings, right? Sonometer strings. Physics sonometer string again, diameter measure can use this micrometer. So you can use this micrometer screw gauge can use to measure thickness of a thin plate, thickness of this sheet. Machine thickness. You cannot use vernier caliper for this, because the thickness is extremely small, right? Smaller than the discount of the vernier, 0.1 millimeter. So you can use micrometer to measure the thickness of this sheet, right? So diameter of a wire, sonometer wire, or guitar string, thickness of a thin sheet, you can measure using a micrometer. So what is this like? Diagram here. So I have a micrometer in my hand now. So this is the instrument we are talking about, right? Right? So have you seen this before? Yes. School start from that. Schooling. We have used especially the mechanics, they use this. Vernier calipers, micrometers, they use this. Right? To measure, measurements done, or they're not. So the measurements done, they have vernier calipers. Right? So let's get familiar with the components of this instrument. Right? So this is much like a U-shaped. So this part is called frame. This is the frame of the micrometer, like a frame method, right? So you can, as you can see, there are two cylindrical parts. One is shorter one, the other one is moving one. When you turn this, you can move this part, right? So this small and fixed cylindrical part, this is called as anvil. It is anvil. Single last one. Kini here, right? Kini here, right? So this is anvil. This is the moving part, which is known as spindle. Spindle. Single term is id. Id. Id malay. Id. This is spindle. This is much like the body of the screw body right? So where's the screw there? Screw right? So this part here, the cylindrical barrel shaped part there, this is known as sleeve. Sleeve. Sleeve sleeve. Right? So linear scale has calibrated on this sleeve. Linear scale maybe calibrated. Linear scale of this micrometer has been different decoration there. So this is the part we call spindle. So this is sleeve. So we have a center line and starting from 0. Normally in typical micrometers, the linear scale is like this. So it has 1 millimeter divisions at above, and also there are half millimeter divisions also, like this. But half millimeter divisions there, like then you have this circular part here. Right? So what I need to tell you, the linear scale has 1 millimeter divisions above and half millimeter divisions below. Right? So so what is the value of this mark? This one is 1 millimeter. Here 2, 3 millimeter. This is 4 like that. So this one is 0.5. This one 1.5. This is 2.5. That goes forward. Half millimeter divisions. Above the 1 millimeter divisions. And the thing here, this part, this is the thimble, right? At the beginning of the thimble, you can see this circular scale calibrated at the beginning of the thimble, this area. Right? With a circular scale like this. Right? So this circular scale has 50 divisions. There are 50 divisions there. Starting from 0, there are 50 divisions. 0, 5, here we have 45. Right? So at the beginning of the thimble, you can see the circular scale, and also this part is known as thimble. Right? You can rotate this. And what is this? The end part. This one is known as ratchet. Ratchet. Right? Didal is the head of the thimble. Right? So this has a very fascinating task, right? May I use right? So you can rotate this spindle by using the thimble or either thimble head. So where the screw? Before that, another thing here. What is this? This part. This is a lock screw. Right? Now you can move the spindle freely because we are not locked the instrument. So now, right. Now what happens? Still you can move. I think lock is not working. I can that. Ah, no. Okay. So now it has locked. You cannot move. You cannot back. Right? So we use this lock screw to lock the spindle. Right? So why it is necessary? Our working scale after you trap the arm, how you measure it? How you measure? How you get the reading from this? Where you need to put the item you are measuring. With the other. You need to trap it in between the anvil and spindle. So if you are going to find the diameter of something, you need to keep it in between the anvil and spindle, right? So like this. Then you need to bring the spindle until is properly touched, right? So what if I use timber to trap this, right? So I can trap it as much I can. What is the result of that? Right? This anvil and spindle put extra pressure on the object we measure. Right? That will cause a deformation of shape, diameter, that will change the diameter of the wire. Right? So to avoid that, there is a specific or special function is there. Right? So when you are taking a measurement, right, in order to move this spindle, remember, when you are so close to the object, you need to move this spindle by using not the timber. You have to make sure you have to use timber head. Right? When the object you measure is properly trapped between the anvil and the spindle, what will happen? This timber head will move with sounding tick. Sounding tick. Now it is freely moving. That means this object has properly trapped between anvil and the spindle. Right? Then we have a tick again. Now it is working. Now it tells you now that is fine. The object has trapped to standard pressure. Now standard pressure has applied on the object to measure. That's fine. Right? Otherwise, if we use the timber, what will happen? It will damage the object to measure. Right? So to prevent that, they have given us this item. Timber head use over pressing to avoid over pressing the object. Understand? So where the screw? Screw it up. This item, this instrument uses screw principle. So where's the screw there? We have the screw here. Screw is here. In the screw is a screw. You got to never know pass. Screw again. I got to screw again. I don't make up the sleeve again. Make a make a spring negative. Make a carbon nepal, make a command. We have a spring negative and tie down the bed. Make sure clockwise okay, but then clockwise may carbon nepal. Right. So the next thing is, so what is the range of this instrument? Maximum length of how much you can measure from this instrument? 10 centimeters? 10? 10? No. And what's the maximum range of how you find the maximum range of the instrument? May maximum range of where then? Tell me a method to find the maximum range of this instrument. Money? No. It has mark on this. Make a mark here. So it is 0 to 25 millimeters. Right? 0 to 25 millimeters. Which means maximum of 2.5 centimeters you can measure. You cannot measure 5 centimeters from this. Because when you measure the if you want to get the measurement, you need to insert that part or that object in between this and you then spin it. May have a gap equal in the panel. Can you measure a diameter of a orange? Large orange? Down the back. Right? What is that? You cannot get a diameter of a tennis ball or rubber ball in the down the back. Right? Should that put 2.5 centimeters is maximum range. Fine. So now we have some idea about this. Make a take copy more make a one over the one master on there. Right. Diagram make a something on code. I'll break that. You over me pass this because I'm done out. Scales එක බලන්න linear scale එක linear scale එක කොහොමද calculate කරලා තියෙන්නේ කියලා බලන්න right තව ඔක අර comparison ගොඩක් වෙලා මම නෑ ඉන්ස්ට්‍රුමන්ට් එකක් තියෙන්නේ